Hey guys, this is Matteo, and it's about time that we talked about animations again. Few days ago I shared this video on my socials, and even if it might seem very simple, it showcases a new strategy to use the IPAdapter that is incredibly effective. This whole animation is basically a crossfade between 9 keyframes, and it only takes 2 IPAdapters. It's not a video to video, there is no rotoscoping, no control nets, it's just pure text to video and takes only 8 gigs of VRAM. Before delving into it, let me stress on the fact that I am not an anime diff expert. All I know mostly comes from the Banodoko Discord community. That is a huge source of inspiration and information. So let me thank Pom, KJ, Nathan Shipley, and all the other guys over there. If you are into AI animation, you should check Banodoko. Okay, enough rhetoric, let's see some action. This is the whole workflow. Here on the upper left I have 9 keyframes. Choosing the right frames is instrumental to a smooth animation, so let me show you how I made these images. As you can see, this is a very basic workflow, no control net or face models to enforce consistency. If I generate 4 of these, you'll see that more or less I get always the same person. These models are extremely biased. The trick is to trigger this bias with sensible prompting. To do that, you need to be specific enough and enforce the model to take from a pool of very specific images, but also generic enough not to give the model reason to derail from the subject. So the checkpoint is realistic vision, and the prompt in this case is extreme close-up, beautiful blonde woman with very short hair, pixie haircut, etc. The trigger words in this case are beautiful blonde woman with very short hair, pixie haircut. That pretty much gives you always a kinda Tinkerbell type of person. Now that we tricked the checkpoint, all we have to do is to change the prompt slightly to cover the full body rotation. In the second prompt, I added left profile. To get the back of the head, it's a little more complicated, but in this case, generating 6 at a time, I was finally able to get a proper one. Of course, using a control net or an IPAdapter to drive the composition would help, but I'm just being lazy here and I wasn't trying to make a perfect animation just to demonstrate the technology. So when you have all the keyframes ready, it might be a good idea to inspect them for small defects. The IPAdapter Plus model that we are going to use is very strong, so we need to remove any detail that could drive it off. For example, in this frame we have an earring that is not present in all images, so I'm going to remove it. Also in the hair there's something that looks like an hairpin. That could be confusing, so I'm gonna remove that too. Here on the neck there's also something weird. If your repair job is not great, you can apply a quick second pass with low denoise using the original prompt. That will take care of merging everything together. Okay, back to Comfy. For the checkpoint, this time I'm using Dream Shaper. Not all models work, you'll have to try them, but Dream Shaper seems to go very well with AnimeDiff. Okay, since life's too short for slow generations, we are going to use LCM to speed up the process. So I use a LoRa loader, select the LCM model and connect the model pipeline. Next, I need a model sampling discrete node and select LCM sampling. In the K-sampler, I can lower the steps to 8, the CFG to 2, and select LCM sampler and SGM uniform scheduler. If I connect the model pipeline now, the generation will be super fast. Yep, perfect. Now it's the turn of the AnimeDiff nodes. I start from use evolved sampling. I drag the mModels pipeline and select Apply Animate Diff Model, then the Motion model and pick the Load Animate Diff model. From the list, I'm using the Animate LCM model, but it actually works with any model even if they are not LCM specific. We'll try later. Finally, I need to define the context window. I drag the context option input and select standard static context options. So there are a lot of options and I don't pretend to understand them all, but the most important thing to change is the context overlap. Animate Diff models are usually trained for 16 frames. To be able to do longer animations, these nodes split the frames in chunks of 16 each and overlap them by a value specified in the context overlap option. In this case, I'm increasing the value to 6. Another important parameter is the beta schedule. I believe AutoSelect would pick LCM by default, but the colors come out a bit washed out for me, so I'm going to use LCM average. Now I connect the model pipeline and we are ready for IPAdapter. First of all, I'm loading all the keyframes. I need a load image node and select the first reference. Then I repeat 8 more times and select all the frames. Now I connect them all together with an image batch multiple. Of course, you can use a load image node that takes all the images from a directory, but I like to see all the frames on the screen. I don't have enough inputs, so I duplicate the batch node, connect them together, and add the remaining images. Perfect. Now that we have a batch with all the keyframes, we can use a new node called IPAdapter Weight that will set up everything for the crossfade animation. Let's see how it works. I connect the image batch and set 6 frames. This is not the duration of the whole animation, but the length of each transition. So in this case, 6 frames by 9 images, it will be a 54 frames animation. If I connect a preview to image 1, you'll see that the node simply repeated each frame. We also have a weight output. This contains the weight values that will be used by the IPAdapter to modulate its strength and generate the crossfade animation. It's a list of float values, but we can visualize them with a mask from list node and a mask preview. As you can see, we are fading them white to black. That are the values in the text prompt. If I set 0.5 and 0, the mask will go from 50% gray to black. Okay, let me set it back to 1. Okay, one image batch is not enough though, because we need to fade from one frame to the other. To do that, I can change the split strategy with the method option. If I set alternate batch and check the difference, you'll notice that the image batch now contains only odd frames, and the weights also changed. I can add a second preview for image 2, and this one will contain all the even frames. With these 2 batches and the weights, we can now crossfade all the images between just 2 IPAdapters. And technically, we could have an endless number of keyframes without impacting performance. Very well then. Let me remove the preview and set up the table. I need an IPAdapter batch and the unified loader. There's no other conditioning, so I'm using a plus model that is very strong. Then I convert the weight to an input and connect the first list of weights and the first image batch. This will take care of the odd frames. I duplicate the IPAdapter, connect the model pipelines, the second list of weights, and the even frames. I can bring everything closer and tidy up a little. Okay, almost done. I'm connecting the model pipeline from the animate div to the unified loader and from the second IPAdapter to the key sampler. The latent batch size will be the total number of frames. We can calculate them, but multiplications are hard, so I'm converting this to an input and connecting it to the total frames of the IPAdapter weights node. We are all set. I replace the preview with a video combine node, select H264 and generate. And just like that, the animation is ready. Now, there are a few issues. The first is that the starting frame is almost ignored and the last one doesn't stay long enough. To fix that, I can add 8 frames at the beginning and at the end and try again. And now it's much better. The second problem is that the animation is a little flickery and there are small glitches. I can try to increase the number of steps that would probably get rid of the flickering, but it sometimes introduces more issues. So what I like to do is to generate a first rough animation like this one, and then apply a second pass that hopefully will get rid of all the glitches. So I'm duplicating the keysampler, change the seed, and connect it to the previous latent. I want to be able to use a very high denoise, so I'm adding a control GIF controlnet. I need an advanced controlnet apply node, connect positive and negative, lower the strength and the end percent to 0.6, and load the control GIF model. As reference, I'm sending the previous animation. Now, in the second pass, we don't need such a strong conditioning from the IPAdapter because the composition is already set. So I'm adding a new IPAdapter batch and connect it to the original model pipeline, skipping the other IPAdapters. So for the second pass, we are only using one IPAdapter, and that will save us some computational power. I need a very light strength, 0.35 should be plenty enough, and connect the second keysampler. For the reference images, technically I would need to generate a new batch that contains all the frames, but it's such a light conditioning that in this case we can reuse either the odd or even frames that we already have. And that's it, we can generate. I mean, it's not perfect, but considering that we are doing everything out of just 2 IPAdapter, it's impressive. In a real-life scenario, you are going to add more conditioning like controlnet, prompt travel, or whatever. At this point, of course, I can add interpolation with arrive and increase the frame rate to get a more fluid animation. Okay, cool. Let's see how it goes with a different AnimateDiff model. Now we have LCM, let me grab V2 and reset the beta schedule to auto-select. Yeah, very nice. The result is less realistic, but the animation very consistent. Let me also try with a different checkpoint. I'll go with realistic vision. Damn woman, don't look at me like that. The blink and the smirk at the end, just perfect. Okay, let's change topic. As I said, this is not really supposed to be used on its own, but more like a template for more complex workflows. Don't worry, I'm not leaving you hanging, I'm gonna show you an example. So the key to get great result is not to fight with AnimateDiff, but exploit its strengths. For example, these models are great for fire, flames, sparkles, and also water, ocean, waves. So let's do that. Here I have a template that basically replicates what we've done before, but instead of 9 keyframes, I only have 2. The frames are very different concepts, so I'm going to need a prompt schedule to get the best results. I need a batch prompt schedule node, connect the clip and the positive conditioning. Now I would need to synchronize the keyframes with the prompts. I could do it manually, calculating the position of each frame in the animation, but that's lame, so I'm going to use a new node called prompt schedule from wait strategy. Here I have a wait strategy input that I can connect to my IPAdapter waits node. I convert the text area of the prompt schedule to an input and connect it to my node. Now I can describe the two frames. One is flames, colorful, fire, sparkles, smoke. The other, wave, ocean, water. The node will take care of distributing the frames for us. And if we change anything in the IPAdapter weights, the changes will be reflected automatically to the prompt. I'm also converting the number of frames to an input since I have them right here in the IPAdapter weight node, and I'm also appending some generic text, like highly detailed 4K sharp. I don't need the positive prompt anymore, and we can try to see what we get. Okay, a nice transition from fire to water. So far we've been using a plus IPAdapter model, which is very strong. Since we are going to add more conditioning, I want to lower the impact of the IPAdapter and use instead the VITG model, which is very powerful and often overlooked. Okay, next I'm going to add some text to the animation. To do that, I'll use the QR code monster. I already have the controlnet nodes up here. I copy and paste them near the keysampler. The model is QR code monster and connect the positive and negative. I'm setting the weight pretty high, but I'm going to use a scaled soft weight node with a multiplier of 0.92 to soften the effect. I've prepared an image with the text latent in it. You can use one of the many text nodes if you want. For the sake of simplicity, I'm going to use this image. I'm also loading the second reference with vision. Okay, so the first controlnet is for latent, and I need a new one for vision. I'm copying this one, connecting them together, adding the missing pipelines, and then to the keysampler. Now I need to schedule the animation in the same way we schedule the fire and water images. I could do that by using a new IPAdapter weights node. This would let me use different values for the controlnet, like for example if I want to lower the weight or whatever, but if I'm okay with using the same parameter that we used before, then I could better use the IPAdapter weights from strategy. I take the strategy pipeline from the previous node, use an image batch multiple to connect the images, and then to the IPAdapter weights node. This way, any modification I do to the main IPAdapter weights will be reflected to the controlnet. This is a very convenient way to keep everything in sync. Now, to connect the weights to the controlnet, I need a latent keyframe batch group node, and I'm finally ready to connect everything together. So image 1 goes to the first controlnet, image 2 to the second, weights in the first latent keyframe, and weights invert in the second. That should be pretty much all I can generate. This is nice already. Let's try another seed. Yeah, pretty cool. Now, since I have this big wave coming, I want to try to have the text vision dissolved into the waters. To do that, I can add another frame that is actually another wave image. So now I have 3 frames, 1 flame and 2 waves. In the text, I duplicate wave, ocean and water. And since I want to dissolve the text vision into nothing, I can simply add a black keyframe. Now I know this is a very lazy way of doing it. I should actually calculate the new weights and whatever, but I mean, it works and it's easy to do, so I'm using this method. Let's see how it goes. Yeah, pretty cool. Let me try with another checkpoint. I have absolute reality here, and I want to try my luck with a new seed. Maybe the vision text is not very readable. I'm increasing the weight of the second controlnet to 1.6. Yeah, would you look at that? Very cool. Okay, let's say I like this one, so I'm gonna upscale it with an NN latent upscale version 1.5. connecting to the latent before the second key sampler, and I'm lowering the denoise to 0.7 because I don't want to lose too much. I'm enabling the video combine and cue prompt. Well guys, we covered really a lot of ground today, and this is only the tip of the iceberg. I believe these new nodes really empowers the animator in you. So I'm looking forward to seeing what you are going to do with these new toys. Let me thank again all my sponsors. Remember that all my code is open source and the workflows always available to all for free. If I can afford to do that, it's only because of the sponsorship. Especially if you are a company and you are making a profit out of my work, well, it's in your own interest to have me working on updates and bug fixes. Okay, I think that's all for today. See you next time. Ciao.